Hey friends, welcome to the YouTube channel All About Electronics. So in this video, we will learn about the line and the load regulation. And we will understand that why these parameters are very important for selecting any power supply or the voltage regulator for your application. So if you take any ideal power supply, then at the given load, even if there is a variation in the input line voltage, then also it should provide the constant output. That means the variation in the line voltage or the input voltage should not have any effect on the output voltage. Similarly, at the given input voltage, even if there is a variation in the load current, then also it should not affect the output and its output should remain constant. But in the actual power supply, if you see, then we do get some output voltage variation because of the change in the line voltage and the load current. So this line regulation and the load regulation shows that how well the power supply or the voltage regulators are able to maintain the constant output voltage despite the change in the line voltage or the load current. So one by one, let us understand them in detail and let us also see for the different power supplies and the voltage regulators how these parameters are represented in the different ways. So as I said earlier, this line regulation shows that how well the power supply is able to maintain the constant output voltage despite the change in the line voltage. So mathematically, it can be expressed as the change in the output voltage due to the change in the input voltage. And if you see the unit of this line regulation, then typically it is represented in the millivolt per volt. And in many textbooks, you will also find that in the percentage, it is also defined as this delta V out divided by delta V in times 100. But very soon we will see that in the datasheets of the power supply, when this line regulation is defined in the percentage, then it is defined slightly differently. But mathematically, this is how it can be represented. So let us take few examples and let us understand how to find the line regulation for the any power supply. So let's say we have a 15 volt voltage regulator, and for this voltage regulator the input voltage range is from 7 to 12 volt, and for this input variation the change in the output voltage is from 4.95 volt to the 5.05 volt. So based on that, let us find its line regulation. So we have seen that this line regulation can be defined as the change in the output voltage to the change in the input voltage. So here the change in the output voltage is from the 4.95 volt to the 5.05 volt, and similarly the change in the input voltage is from 12 volt to the 7 volt. That means here this line regulation is equal to 100 millivolt divided by 5 volt, or we can say that is equal to 20 millivolt per volt. That means if the input voltage changes by the 1 volt, then the change in the output voltage will be equal to 20 millivolt. That means for the given voltage regulator, when the input voltage is equal to 8.5 volt, at that time we are getting the nominal output voltage that is equal to 5 volt. But whenever the input goes to the 7 volt, then the output will change by the 50 millivolt and it will become 4.95 volt. So from the line regulation, we know that for the given change in the input voltage, how much output voltage will change. So while selecting the power supply or the voltage regulator for any application, by looking at this parameter, we know that how well our power supply will remain stable against the change in the input voltage or the line voltage. So for the voltage regulators, typically the input is a DC voltage or the unregulated DC voltage. But when it comes to the power supplies, like the SMPS power supply or the linear power supply, then their input is the AC line voltage. So normally the AC line voltage is equal to 230 volt, but typically this line voltage may change by the plus minus 10%. But here let us consider little broader range, and let's say this AC line voltage changes between the 200 volt to the 260 volt. So even with this change, the change in the DC output voltage should be as minimum as possible. So let's say for a some 5 volt DC power supply, when the line voltage is changing from the 200 volt to the 260 volt, then there is a change in the output voltage from the 4.9 volt to the 5.1 volt. So for that, let us find its line regulation. So once again, we will use the same equation. So here, the change in the output voltage is from 5.1 volt to the 4.9 volt. And similarly, the change in the AC input voltage or the line voltage is from 260 volt to the 230 volt. That means here, this line regulation is equal to 200 millivolt divided by 60 volt. And if you calculate the value, then that will come out as 3.33 millivolt per volt. That means for the given DC power supply, if the line voltage changes by the 1 volt, then the output voltage will change by 3.33 millivolt. So here, if you compare the specs of the line regulation for the given DC power supply and the voltage regulator that we have discussed earlier, then it seems that this SMPS based power supply provides the better line regulation. Because if you see over here, then for this DC power supply, its line regulation is equal to 3.3 millivolt, while for the earlier voltage regulator, that was equal to 20 millivolt per volt. But in reality, if you see the actual variation in the voltage, then for this SMPS based DC power supply, that variation is more. Because here, that is varying from 4.9 volt to the 5.1 volt. Because here, if you see the change in the line voltage, then that is also more. And in fact, that will remain true for any DC power supply. So typically, for the power supplies, this line regulation is expressed in the percentage. So typically in the data sheets, when this line regulation is mentioned in the percentage, then it is defined over the specific input range. So for example, let's say for a some 5 volt DC power supply, the line regulation is equal to plus minus 0.5%, and it is defined over the input range of 100 volt to the 280 volt. So with the given line regulation, if we see the change in the output voltage of the power supply, then that will be equal to 0.5% of the 5 volt. But the 5 volt is the nominal voltage of the DC power supply. And if you calculate the value, then that will come out as 25 millivolt. So if we consider the plus minus 0.5% variation, then the change in the output voltage will be equal to plus minus 25 millivolt. So we can say that the change in the output voltage will be from 4.975 volt to the 5.025 volt. And in fact, that is a very good line regulation. So for the power supplies, typically this line regulation is mentioned in the percentage. But if you see the voltage regulators or the LDOs, that is the low dropout voltage regulators, for them, this line regulation is typically mentioned in the millivolt per volt or the percentage per volt. Because many of the voltage regulators and the LDOs are typically used in the low voltage applications. And in such applications, many times a very tight tolerance are required. So in such applications, this line regulation is mentioned in the millivolt per volt. So we have already seen that how the line regulation is represented in the millivolt per volt. But similarly, many times this line regulation is also represented in the percentage per volt. So this line regulation in the percentage per volt is defined as the change in the output voltage that is normalized to the nominal voltage divided by the change in the input voltage. And for the percentage, it is multiplied by the 100. So once again, let us take one example, and through that, let us find out the line regulation in percentage per volt for the given same 5 volt regulator which we have seen earlier. So we have seen that for the earlier 5 volt regulator, the input voltage was varying from 7 volt to 12 volt, while the change in the output voltage was from 4.95 volt to the 5.05 volt. So if you see the line regulation in percentage per volt, then it can be given as this 100 millivolt divided by the 5 volt, that is the nominal voltage of the regulator divided by the change in the input voltage. So in this case, that is also equal to 5 volt. So if we further simplify it, then it will come out as 0.4% per volt. So from this we can say that With the 1 volt change in the input voltage, the output of this regulator will change by the 0.4% of its nominal voltage. So in this case, with the change in the 1 volt of the input voltage, the voltage regulator output will change by the 0.4% of the 5 volt. So here, if the input voltage changes by the 2 volt, then the change in the output voltage will be equal to the 0.8% of the 5 volt, that is equal to 40 millivolt. So this percentage per volt representation also gives us the clear indication that when the input changes in the specific range, then what is the expected change in the output voltage. And many times for the LDOs also, this line regulation is mentioned in the percentage per volt. So let us take one more example to understand it clearly. So let's say we have a 3 volt LDO and its line regulation is equal to 0.1% per volt. And let's say the input to this LDO is varying from the 4 volt to the 3.5 volt. Let's say the input to the LDO is applied via the battery, where the battery voltage is changing from the 4 volt to the 3.5 volt. That means initially it is equal to 4 volt, and as the battery discharges, then it reaches to the 3.5 volt. So here we can say that the change in the input voltage is equal to 0.5 volt. So once again, the line regulation in the percentage per volt can be given by this expression. So here, to find the delta V out, we need to multiply the line regulation with the delta V in as well as the nominal voltage. That means here, this 0.1% will be multiplied by this 0.5 volt as well as the 3 volt, because the nominal voltage for the LDO is equal to 3 volt. And moreover, it will also get divided by the 100. So if we see the change in the output voltage, then that is equal to 1.5 millivolt, which shows that even if the input changes from the 4 volt to the 3.5 volt, then the change in the output voltage is equal to only 1.5 millivolt. So while selecting the voltage regulators or any power supply, we should select the such power supply which has the lower line regulation, so that even if there is any variation in the input voltage or the line voltage, the change in the output voltage will remain minimal. So similarly, let us see the load regulation. So the load regulation defines that how well the power supply or the voltage regulator maintains the constant output voltage despite the change in the load current. So this parameter is also very important because many times the power supply will see the abrupt change in the load current, and in such case the change in the power supply voltage should be minimum. For example, the power supply which is driving the CPU might be operating in the sleep mode at one time, but suddenly at the another second it is operated at the full capacity. So during this abrupt change in the load, if there is a sudden drop in the voltage beyond a certain limit, then it is quite possible that the CPU may not operate properly. So that is why this load regulation is also very important specification of the power supply as well as for the many voltage regulators. So mathematically, this load regulation can be given as the no load voltage minus full load voltage divided by full load voltage. And for the percentage, of course it is multiplied by the 100. So here, this VNL is the no load voltage of the power supply when the current through the power supply is minimum. And similarly, this VFL is the full load voltage of the power supply when the current through the power supply is maximum. So for any good power supply or the voltage regulator, the value of this load regulation should be as minimum as possible. So let us understand that by taking one example. So let's say we have a 5 volt 2 ampere power supply. So for this power supply, let's say the no load voltage is equal to 5 volt, and similarly the full load voltage is equal to 4.95 volt. That means whenever the current to the power supply is maximum, at that time this full load voltage is equal to 4.95 volt. So based on that, let us find its load regulation. So as we have seen, this load regulation can be given as the no load voltage minus full load voltage divided by full load voltage. So here if you put the value of the no load voltage and the full load voltage, then the percentage load regulation will come out as 1.01%, or approximately we can say that is equal to 1%. So in the data sheets for any power supply, if its load regulation is equal to plus minus 1%, it means that even at the full load, its output voltage will not change by more than plus minus 1%. On the other hand, suppose we have another power supply with the same specs but with the value of the load regulation as plus minus 0.5%, then that power supply will perform better at the full load. That means while selecting the power supply, we should always check this specification. Now many times for the low dropout voltage regulators or the LDOs, this load regulation is also defined in the millivolt per milliampere. So it shows that when the load current changes in the milliampere, then how the output voltage will change in the millivolt. So now let us take the example of the 1.3 volt LDO. So let's say for the given LDO, the current is changing by the 100 volt, and with that change in the load current, the change in the output voltage is equal to 10 millivolt. So we can say that for this LDO, the load regulation is equal to 10 millivolt divided by 100 milliampere, and that is equal to 0.1 millivolt per milliampere. So we can say that for this LDO, when the load current changes by even a 1 milliampere, then the change in the output voltage is not more than 0.1 millivolt. So by knowing this spec, the designer can select the specific regulator or the power supply based on the load current. And based on that, it can fine-tune its design. And that is why this load regulation is also very important parameter. So I hope in this video you understood what is line and the load regulation, and while selecting any power supply or any voltage regulator for any specific application, why it is important to check these specifications. So if you have any question or suggestion, then do let me know here in the comment section below. If you like this video, hit the like button and subscribe the channel for more such videos.